right, thanks everyone for joining this session. This session is Postgres for Oracle DBAs, and it's geared for anyone who may be new to Postgres or anyone with an Oracle background looking to transition or migrate over to Postgres. My name is Twimi Tran. I'm a database solutions architect at AWS, and in my previous roles, I was an Oracle DBA. And here with me today is my colleague Chandra. Chandra, would you like to introduce yourself?
Hello everyone, my name is Chandra Patiwada. I'm a database specialist solution architect focusing primarily on commercial to open source migration, such as migrating from SQL Server or Oracle to Postgres. Thanks.
All right, so let's move on to the agenda. What we're going to talk about today is why Postgres. Postgres is growing in popularity. It's a database engine that developers are utilizing for their use cases, as well as it's a great migration target for large enterprise databases like Oracle and SQL Server. And then we'll jump on over to talk about the key concepts, which would be the fundamental differences between Oracle and Postgres. And then we'll note out some considerations to take if you're moving from Oracle to Postgres. There's things that operate a little bit differently in Postgres compared to Oracle. And then we'll highlight some tools and services for your migration projects if you may have it, if you're looking to. And then wrap it up with some key takeaways. We've carved out time towards the end to answer any questions that you may have. Okay? So I'm going to start off with why Postgres. And I mentioned earlier that it's growing in popularity every year. And it's not a new database engine. It's over 35 years old. But it's growing in popularity due to its costs. There's no cost to license it. It's truly open source. And the major cloud vendors have a database as a service, so you don't have to worry about vendor lock-in. At AWS, we have RDS Aurora for Postgres, which is open source compatible to Postgres. And I mentioned earlier that it's popular with developers because Postgres supports a wide array of programming languages, like Python, Java, and Ruby, and those are just to name a few. But it also supports newer use cases, like say GenAI use cases. You can turn your Postgres database into a vector data store, and you can store, index, and query your vectors there. And I mentioned that Postgres is a great migration target for enterprise databases because, as we mentioned, Oracle and SQL Server have very expensive licensing costs, and there's no cost with Postgres being open source, and it's highly compatible. We'll see some differences in the code of PL/SQL versus PL/PG/SQL, but it's a great natural destination choice for enterprise databases. So now let's move on to the key concepts. Again, this would be the fundamental differences between Oracle and Postgres. And to start, we're going to talk about multi-version concurrency control, MVCC. So MVCC, this allows a database, so readers don't block writers, and writers don't block readers. So it's a concurrency control mechanism. So instead of using like table locks and so forth, what Postgres utilizes is a multi-version model, where so at any point in time, the database will have multiple versions of the same row to prevent blocking. And there's visibility rules which are utilized to see which transaction can see which version of data. And transaction IDs are what Postgres uses to define those visibility rules. So a key thing to understand the difference of here is how Oracle and Postgres, the undo management. The undo management from Oracle that you may be aware of is Oracle manages the undo in rollback segments outside of the table in its own data storage. It's at the block level, and really there's no DBA intervention required. You just turn on automatic undo management and just specify your table space. And then Oracle will handle the management for you. So since undo is completely separate from the table, you don't have to deal with table or index flow. Or Postgres manages the undo within the table with the multiple versions. So you do need to have some care and precaution to clean up all the dead versions. Otherwise, you're going to have table bloat, and that will affect your performance. So let's just walk through MVCC and the behavior of like how to determine the visibility rules. So as I mentioned earlier, transaction IDs define the visibility rules that Postgres determines of what transaction can see, what versions are available. And xmin and xmax, those are system table columns. Xmin would be the transaction ID that inserted the tuple is the row, and xmax would be the transaction ID that removed it. So say here we have a transaction ID of 100, and that inserted the first row. And the next transaction ID is 101, and it inserted the second row. So you can see here that xmin was populated with the transaction ID. But say we want to update the table, and an update is essentially a delete and an insert. But since we're managing the undo within the table, we're not going to delete that version of the row because other sessions may still require it. So we're going to mark the xmax with the transaction ID, which currently is 102, and then add the inserted row and mark it as xmin. So these determine the visibility of what a session can see. And over time, if you do this a lot with a lot of deletes and insert, your table's going to grow and there's going to be a lot of old versions. And over time, those old versions, those tuples, they won't be required anymore. So we'll need a vacuum process to clean up those dead tuples so we can reclaim that space for inserts, future inserts. And this will prevent that table bloat that I was just talking about earlier. So now we're going to talk about vacuum. So vacuum is a maintenance task, and it cleans up those dead tuples from the pages. And it can be triggered manually, or there's an auto vacuum process that gets triggered if a threshold is reached. And when auto vacuum, if it's triggered, it'll run some background worker process to reclaim those dead tuples. And there's two main types of vacuum. Normal is the one that we just walked through where the tuples are reclaimed, like removed, marked for reuse of the space. But full, it's when you completely rebuild that table or the index to release the storage back to the operating system. Full requires exclusive locks, so you don't want to use it that often. There's a vacuum type called freeze, and we're going to go into that and talk about transaction ID wraparound. So it'll make sense when I talk about freeze just in a little bit. But you also can run vacuum analyze, where after your vacuum, you can just run analyze to collect and update your statistics. So as I mentioned, with the multiple versions of your data stored within your table, that's going to cause bloat over time. And you don't want your table to be bloated with all these old versions because that will affect your performance. So if you run a query, there's more data that needs to be sifted through. So you're going to have more I/O, your memory is not going to be as efficient. So you want to make sure that you have routine vacuuming set up. As I mentioned earlier, there's auto vacuum, where it triggers when a certain threshold is, and that will release those, clear the bloating. So you just want to make sure that you are on top of the vacuuming so it doesn't cause performance degradation. So earlier I mentioned vacuum freeze, where you want to prevent transaction ID wraparound. And what that is so a transaction is a 32-bit integer, and you can think of it as a circular counter. It starts at 0 and can go up to 4.2 billion. But 2 billion is reserved for the past, and 2 billion is reserved for the future transaction IDs. And we can't have it wrap around meaning utilizing all the transaction IDs and reset to start over, because that would be essentially data corruption. Because the lower the transaction ID generally shows that the transaction is an older version. So we want to prevent a wraparound to happen in Postgres. And through thorough vacuuming is a method that you can do to prevent this. Okay. So here's just some tips to try to minimize your bloat and prevent transaction ID wraparound. Is just make sure you're vacuuming routinely, monitor the index in your tables for growth, and tune your auto vacuum or vacuum process. Sometimes the default setting may not be enough. And if you have a large table that has a lot of write activity, maybe you want to just do a separate vacuum process for that table just to keep it up instead of just relying on the auto vacuum, right? So again, the vacuum would release the space back if you do a full, but that takes exclusive locks. So what you can do instead is you can rebuild index online, which is an online option, or you can just use an extension that allows you to rebuild those indexes, like PG repat. And another way to avoid the bloating in transactions is you want to avoid having long-running transactions that hold up the transaction IDs from being released and reclaimed. Yeah. Well, you try to tune them.
Sometimes applications are designed for, like, you have sometimes you have online transactions that's already stored. Are there ways to mitigate the damage while you're running? Now you just have to have more memory?
Well, there are ways.
So first, it's highly recommended to avoid that situation, avoid the transaction wraparound situation. So there is a threshold that you can configure at the Postgres, and in case if you are using Aurora, then that threshold is being configured. So when it reaches a certain transaction ID limit, then it sends an alert. And beyond that, the database automatically shuts down. So you have an option to fix that TID issue. Yeah. Yes.
Yeah, and so I didn't mention the other one where you can do vacuum freeze. So that's the process. So before it gets to wrap around and to shut down, you want to freeze some tuples to release it back. So the takeaway here is be sure you have routine vacuuming going on. Like, you didn't have to worry about that at Oracle, but in Postgres you do. And yeah, you're right. There's going to be long-running transactions, but just.
I understand that was a difficult question. I'm just asking, based on the scalability. This is what I'm curious about. So, what do you do when you get into those situations? All right, I need to do research.
Yeah, two things. First, monitor vacuum. Monitor the status of vacuum across all your tables and at your database. So there are some system tables. So the most common system table is pgstat user tables. So looking at this table, you can find when was the last time that the vacuum ran on what tables, and when was the last time that the statistics are updated in tables, and the rough estimation on number of rows and everything. You can get it in one snapshot through a view called pgstat user tables. So that's a first in hand. And second thing is, make sure that your auto vacuum is always enabled, because in some environments they do disable, especially during if there is any ETL operation happens during certain times, then they disable to consume resources, and after that they re-enable the vacuum. But oftentimes if they forgot, then they only get into this problem. So yeah.
Okay, right. I just, because is an earlier session, and one of the people in the audience said that you just can't have vacuum running because it automatically gets an exclusive lock on the table, so effectively you're shutting it down. So that's why I was curious about that, because the impression I'm getting here, and I understand that that's probably wrong, is that it seems like that you just have to run vacuum constantly during the day, or can you get away with doing like a normal maintenance schedule when it comes to deploying 24 hours or something like that?
Yeah, I can answer to that. So there are two types of vacuum operations you can do. One is an auto vacuum, which is by default, which automatically runs as and when a certain threshold number of dead tuples exist, and that won't cause any blocking. But it takes some resources, some system resources to clean up the tuples, to clean up the dead tuples, right? Yeah. So, but let's assume that you have a huge table, a table with 100 million rows, example.
You need to do the full vacuum, right?
Yes. Yeah.
All right, so the auto vacuum is essentially an
Online.
rebuild.
Online.
Okay, all right.
Yeah.
Yeah. Yeah. And you can even kill it, or it automatically stops, if it says any issues, and it automatically resumes back. Yeah. So you won't see any issues in terms of blocking with the auto vacuum. Yeah.
All right, so let's move on to considerations to take note of if you're moving from Oracle to Postgres. And we'll start with table spaces. So in Oracle, we have table spaces for everything: tables, index, undo. And in Postgres, a table space means something completely different than in Oracle. In Postgres, it's just merely your directory on a file system. So with Postgres, unless you have a database that spans multiple physical drives, you just need to have that one table space. And having more, the point here is try not to go in from Oracle to Postgres and try to recreate all the table spaces that you had in Oracle over at Postgres when you don't really need to, because having more table space in Postgres can complicate your upgrades and your backups. So just be aware that table spaces mean something different in Postgres than Oracle. And next would be synonyms. So in Oracle, we use synonyms everywhere just to alias, and we don't have to fully qualify the database objects. Postgres doesn't directly support synonyms, so instead you would want to use search path instead. And search path you can think of as like setting your $path variable at your operating system level to find the executable. So you would specify the order of the schemas that you want Postgres to look into to find your database object. So Postgres will look into that order, and it finds that object and will return it. And if there's not found within that schema list, you'll get an error that that table or object not found. So search path instead of synonyms. And talk about Postgres extensions. So with Oracle, all the features and functionality and options are already built into the database. But with Postgres, it has some core features. And if it's designed to be extensible, you can add more features to it by utilizing the Postgres extensions that are out there. And there's many extensions out there. It's supported by a large community. And once you load these extensions into your database, it just acts like the features and functions just as if it was built in. And this is just some of the popular extensions that are out there. And earlier I mentioned that you can turn your database into a vector data store. To do that, that would be the PG vector. That's the extension that's noted here. So there's a bunch of extensions out there. Just take a look and see what features and functionality that you can add to your Postgres database.
Yeah, one thing to add it here on the extensions.
Yeah.
Here, the power of Postgres comes with extensions. Postgres is highly extensible because it's driven by, all these extensions are driven by the community. And in Postgres, you can see thousands of extensions. And the popular extension is PG vector is one extension, and FDW is another extension, and PG partman, that is to partition the tables. And we also built our own extensions on Aurora. So using that extension, you can directly copy data from Aurora Postgres to S3 bucket. So, yeah.
Yeah. Thanks, Chandra. So let's move to indexes. So here's just a common list of indexes that Oracle would use. And if you're going to migrate over from Oracle to Postgres, we're going to have to recreate the index. We have to create the indexes what you had in Oracle onto Postgres. So Postgres has B-tree indexes and some indexes that are compatible to what you have in Oracle. So here you want to take consideration that Postgres has a lot more indexes than Oracle has. So you want to utilize and see if there's an index that you can use instead. Because sometimes, when you migrate your indexes over, majority of the time it'll work as good as it ran in Oracle. But there's going to be a few that don't run the same. So you can just look at the indexes, make sure that you learn that there's a lot of indexes out there, and instead of doing some complex code to do something, there might be an index that's already there. Like say, for example, this GIN index. You can use that for full text search. And here we just have to create an index to make that full text search happen instead of just this large, complicated process that you may have not knowing that the index was there. You want to add anything else with the index?
I mean, there are like 4 types of indexes as you covered.
Yeah.
The default is B-tree, and second one is GIN or just index. Both supports full text search. And also has a BRIN index. It's a block range index. And the last one is using the PG vector. You can build GenAI applications using one of these indexes. Yeah. But one thing here, note is Postgres indexes are always separate. There is no way to sort the table. I mean, there is no way to create a clustered index on Postgres. It's always a separate structure. But if you want to sort the existing data pages, then the only way to do it is using a command called clustering. You can cluster existing data pages based on an existing index. That's called clustering, but that's a one-time operation. So the best use case is if you have a read-only database, or mostly read-only, where the sorting of this data is important, then you can cluster that index as a one-time operation. So that's the major difference. Yeah.
Yeah, thanks. So let's move to data types. So in Oracle, there's only just a few data types that are normally used: varchar 2, date, number, and if you have some lobs, it would be clob and blob. But Postgres, there's 64 base types, so we have a lot more data types that Oracle has. And you can add more data types by those extensions that we mentioned earlier. And it's important to choose the right data type because the data type has an impact on your database design and performance. So say, for example, here, if you were to migrate from Oracle to Postgres, and we have number versus numeric, it looks the same. And you think simply just, okay, wherever you see a data type of number, let's convert it to numeric. But it's completely different. You can see here that the Postgres one supports like 131,000 more digits before the decimal point, and about 16,000 more digits after the decimal point. So it's a lot larger data type.
Let's assume if you have a scientific-based application where every digit matters. I mean, not to that extent.
Yeah, that is very high.
Yeah.
And I think, I remember reading before, it was some math like based on that,
Yeah.
but that's why it's such
Extreme use
for
case.
financial, yeah.
Yeah.
I know, I just mean like that's because you can, you should.
Exactly.
Yeah. More than 4 digits, it's not needed for the financial applications. But if it's
99.5% of the users are going to be able to put in some sort of random feature in the spreadsheet and they download it anyway. But yeah, no, I
Exactly.
Just curious.
Yeah.
Yeah.
So if you're going to be migrating over, and say you have like a migration tool that like automatically converts your thing, be cognizant that choose the right data type for like just don't automatically go from number to numeric. And here's just a guide, just like a good guide to use either int or big int instead. You know, it depends on your precision type. And again, because the larger data type is going to affect your performance. And so this is just a guide. It's like numeric is kind of like setting a clob for your data type, and you don't want to do that. So just be cognizant of that. Number and numeric don't mean the same thing in Postgres.
Just want to add one more thing on the data types. So, yeah, following the right data type is one thing, and the second thing is, if you are using UUID data or GUI data, then oftentimes most of the DBAs tend to create a varchar data type, right? But the varchar takes some space, of course, for the UUID, and that too it's a random, right? So for that, we recommend you use an extension called UUID. So you can create a data type using an extension as well. So if you use that UUID extension, then it's highly compressible compared to text data type, so that you can keep more data within the same page. And that the chances of page splitting will be minimal if you use UUID data type. Yeah, and there are more recommendations. Yeah, but this is just one example to pay attention to the data type. Yeah.
So now let's talk about null behavior, because Oracle and Postgres, they handle nulls very differently. So nulls and empty strings are equivalent in Oracle, but it's not in Postgres. Like an empty string is not the same thing as a null. So if you see here on this example, we run a coalesce, and that's when we provide like two inputs, and it'll return the first one that returns a null. And so here you see Oracle treats the first input as a null, so it returns A. But we get a different value in Postgres. So you want to make sure that you understand how null behaviors behave, because if you're going to migrate over, you might have outcome that is not expected or not correct. And another example is for the null behavior is in terms of the string concatenation. So as we mentioned earlier, Oracle treats empty strings and nulls the same. So here if we run this string concatenation where we're going to query the first, middle, and last name. But there's only two full names here that has a middle name. The rest, that means the middle names are null, but it returns all 10 rows because nulls and empty strings are the same in Oracle. But if you look on the Postgres side, empty strings and nulls are not the same, so we have different results. So just be cognizant of that when you do migrate over to understand the different null behavior type, okay? Because in Postgres, if you concatenate a null with anything else, you still get a null, and that's why we see the different data results. And if you want the same functionality in that, that coalesce, use the coalesce function for each of the column, Or there's a built-in function in Postgres that you can utilize instead, that concat_ws, to get the same results that you would expect in Oracle. And here, it's to show that unique constraints with this null behavior, you may get different results as well. Because in Oracle, 2 nulls, they're treated as equal. But in Postgres, null doesn't equal null. And so in the first example, you'll see that if you're inserting another row, you'll get that unique constraint violation. But in Postgres, we're not going to get that unique constraint violation. But if you want the same behavior, there's a nulls not distinct that you can use instead. Okay? Now we're going to move to exception handling. So in Oracle, there's an exception handling in pretty much every procedure or function. And here we'll see that we have the same data type. This is in PL/SQL, and the other one is in PGSQL. So you can see that it's very compatible. It's the same. The only difference is the header and the footer. But what this function is doing is you pass it the last name, and if data is found, then it'll return a first name. If it's not found, it'll return a null. Okay? But here with Postgres, regardless, if you'll see that the exceptions don't behave the same. Here, if we were to run this query in Postgres, if the data is not found, it's not going to have the same exception that will be raised. It'll just return a null. So if you want the same results, we're going to have to use the strict keyword to get that behavior that you were used to in Oracle for that data not found. Okay, to get this result. And exceptions in Postgres are expensive because we'll talk about subtransactions later. So if you have if you're going to migrate your code over, see if you really need those exceptions, because like say for here, if no data is found, it's going to return a null. But the way Postgres handles null differently from Oracle, we didn't need that null exception to be raised because it was just going to return a result. So let's talk about like subtransactions. So we mentioned that with exception handling, so implicitly a subtransaction will be created, and subtransactions are a heavy lift in Postgres. They have their own IDs, and it occurs overhead just to track all those subtransactions. And there's like a subtransaction overflow if you like cache more than say 64-bit. So migrating your code from Oracle to Postgres, look through where you have exception handling. If it's not required, try to remove it because it is an expensive operation in Postgres. And then we'll move to query hints. So Oracle, you can use hints to direct how the optimizer is going to run with the execution plan, right? But in Postgres, it's treated as comments. So what you want to use instead is if you want to really use your hints, there's an extension called PG Hint Plan that you can use, you enable to true, to get these, to direct the optimizer to choose the scan method or join method that you would think is better than what it was outputted. And to do so, here is like you can see that you just turn it to true, and then you'll see that it uses the hint where here it says to do a hash join, where the earlier one was like a nested loop. All right, so let's talk about, this is a high level of just the migration tools and services that are offered if migrating from Oracle to Postgres. So these are just the options that AWS provides, but we do have like 3 options. AWS DMS, that stands for Data Migration Service. We have a Fleet Advisor. So say you have like a fleet of Oracle databases, you can use this Fleet Advisor to help inventory and assess what database systems that you would like migrated over. And let me just move over to that first real quick. So here, it's just, it helps provide that inventory for your assessment of your database workloads to move over. But the key one here is the schema conversion tool. So it can help convert your code from your source database to a target database. It can provide a assessment report to show the level of effort that's required. And then DMS, the data migration service, is what we would use to replicate the data to the new data source. And the replication instance, you would just have to pay for that, and it's a self-service tool. And earlier I mentioned that this talk was about Oracle to Postgres, but DMS supports many sources and targets. And this is just a list of some of it that it supports. All right, so just to take up what the key takeaways here is vacuuming is very important. It's very important to have routine vacuuming in place, to monitor it, to tune the vacuum, and take advantage of the Postgres, not just the native features, but also the extensions. You know, Chandra mentioned that there's many extensions, and Postgres was meant to be extensible. So take a look at those to add features and functionality to your database. And we talked about some of the common migration mistakes in the sense of migrating directly over and some for the data types or the index. Take a look into, you know, what's proper for your database when migrated over. You know, nulls behave differently, exception handlings are more expensive, and so forth. And we just covered the migration tools and services, and that's very helpful in your project to assess and to analyze and convert your data over. So yeah, now we're just at any questions that you may have.
So how many of you are using Postgres? Okay, yeah. So my question is, how many of you are using Postgres? Okay, I see 3 of you are using Postgres, okay. And how many of you are planning to migrate from Oracle to Postgres? Do you have any stack to migrate from Oracle to Postgres in current or in future? Okay.
Everybody's considering it.
Yeah?
Yeah, because 2020 Gartner report says that 40+ percentage of customers are either started using Postgres for their new application development or planning to migrate the proprietary databases to open source, such as Postgres or MySQL. But in case Oracle or SQL Server, Postgres is the most common target to migrate. Sure.
One of the things that customers that I'm working with and I'm talking to is really sort of the performance implications, especially after they have done the migration. Because Oracle, of course, has a lot of built-in mechanisms that I'm not as familiar with Oracle side, but my understanding is that there are caching mechanisms and other things that have been that are being done for you. How has your experience been on the ones for those ones that are getting migrated over to Postgres?
Yeah, especially I'm comparing with Aurora Postgres because, right. So with Aurora Postgres, you have most of those features are already available with Aurora Postgres. And on top of it, you can even add on. Let's say if you want to implement cache, then we have read optimized instances where you can keep all the temporary objects like the temp table or any query that needs to sort the data. This kind of stuff, you can keep it in the compute instance itself. And if you even want more cache data, then you can use a cache layer on top of it. So in that way, you can achieve it. Yeah.
From a performance perspective, do you see them to be compatible with what was there? I mean, I know
Yeah.
it's a very broad question.
Yes.
But so what is your experience?
It always changes from workload to workload. Every workload is different. Yeah, but there are ways to optimize it. Yeah, there are n ways to optimize it, and yeah.
Is Aurora Postgres typically the primary target that you're taking to Oracle?
Yeah, I would say we have like more than n databases. We have RDS Oracle and Oracle on EC2. And in case of Postgres, we have Postgres on RDS and Postgres on Aurora. So these are, if you want to move to the open source relational databases, then these are the two target databases. And some customers, they're even migrating to Aurora MySQL too, because their workload is different. The transaction properties of their existing workload is, suits to MySQL for some use cases. It's all based on the transaction properties of your data. Yeah. Thanks.
More of a general question, so what, and maybe if you can, it's fine. Why does Amazon trying to get more people into Postgres? Did you both work for AWS, correct?
Yes. So the question is why Amazon.
Or rather, what is the customer that Amazon is looking for? So aside from the open source, the save and licensing costs, what kind of customer do they think is going to be attracted to Postgres?
Oh, it's all driven by the customer community itself. Yeah, we make the decision based on, we get the feedback, continuously collect the feedback from customers, and based on that, we implement our products.
Yeah, a lot of times customers want to move, say, from off a commercial database like Oracle and SQL Server to save on licensing costs. And Postgres is just more compatible, it's most compatible to it than, say, compared to, say, MySQL.
And that's what I'd originally been told. I was curious. But yeah, I'm here. I work for a consultancy, and I tend to get a lot of the odd requests that come in from sales where they're looking for help, not just Postgres, but customers who want to do migration from Mongo or Redis cache or things like that. So I thought I wanted to figure out how much need is there for these sort of things. And again, they're looking to move away from SQL Server and Oracle. And so
Yeah.
they're looking at different options.
And
Yeah.
also, yeah, continue.
So I mentioned like that schema conversion tool, and part of that during that assessment and that, it tells you like it tells you what database engine is more applicable to move as a target to, So even though we say on a blanket statement that, SQL Server and Oracle, Postgres has the most compatibility with it, you can run that tool and you can see through, what code is converted over and what's not, the implications and how heavy of a lift to migrate to that different thing. So it'll help you choose which database engine too is most.
Amazon, I think, on the storage anyway, so food costs, so I guess it doesn't really matter.
It's a pay-per-use. Yeah. You don't need to pay upfront costs. That actually saves a lot of money. Yeah. And also coming back to Postgres, if you look at the number of products built on Postgres, almost every major cloud provider is taking bite and fork of Postgres and building their own products.
Yeah.
In case of us, we have RDS and we have Aurora and we have Redshift is also built on using Postgres. And we have Babelfish. Have you heard about Babelfish? Babelfish. Babelfish is also built on Postgres, but that behaves like SQL Server. Yeah, you don't need to rewrite your entire source code. It is as if like moving from one SQL Server to another SQL Server. And it behaves like SQL Server, but that's built on Postgres. Yeah.
And I spend my day in Azure, yeah, I mean, I've got Microsoft is looking for all these different solutions.
Yeah. Yeah. And we have two more products are built on Postgres. We have Limitless, which is available on GA. We just released it just 5 days back. Yeah, Limitless is another database which is on GA. And yeah.
So how long is it going to take to do an average Oracle migration into Postgres?
It again depends on your workload. It depends on how complex your current workload is. But you can take advantage of schema conversion tool as she mentioned, and that tells how much time it takes. It gives some estimates if you use SCT. Yeah, and it's a free tool.
Yeah, it gives an estimation, but yeah, it really depends how many objects that you need to convert, like how many functions that you have written in PL SQL and any functions. So it really depends on that, more so than just like, it's broad.
And when you're doing a migration, where are you spending most of your time?
In migration, where we are spending most of the time, is that a question?
Yeah, what part of the migration?
Rewriting source code. Because
The assessment and the rewriting the source code and converting it over to that target destination. Because that schema conversion tool, it can do some of it, but there's some that it can't do automatically, and then that would require manual intervention to rewrite that code.
Yeah. And also look at the new features which we are going to add on Aurora and the rest of the services, especially on the migration in upcoming months. You'll see a lot of improvements, especially on migrations. Yeah. So-
What if people use Apex? Do you have something to migrate from Apex to?
Yeah, I heard about Apex. Apex is about, they have multiple products, right? So which product you are targeting to?
Like application, quick application development,
Oh, okay, yeah. So no, that I'm not sure, sorry. So your question is, sir, could you repeat your question?
We do migrations as well from Postgres, and the main problem, as you said, one is like function and stored procedures, yes, and another one, so some clients have a lot of applications in Apex, and Apex is part
Got
of
it.
our universe, and we stuck with that.
Profile it. You can profile the SQL statements that are coming from your application. And based on that, you can start rewriting it. But I see your challenge. I see the challenge, because if your application code embed, a SQL code embedded in the application, as long as you are using any SQL which is aligned to ANSYS standards, it will work on Postgres. Yeah. Because Postgres SQL, the SQL as a language, ANSYS SQL I'm talking about, it is similar, mostly similar across all these products. All right, similar between MySQL, Postgres, SQL Server, Oracle. It's all similar. But if you use any Oracle proprietary functions or features, there you face a problem, especially if you use it in the application layer. Yeah. So that's the reason we made Babelfish. Yeah, that behaves like as a SQL Server. Yeah.
Yeah, I tried it. So do you have any ideas of what the overhead of translating from an SQL dialect to Postgres, comparing to the native Postgres functions?
Yeah. So it's using Babelfish, right? Okay, first, there is no, Babelfish behaves like SQL Server. That means it takes SQL Server input and it gives the output exactly like SQL Server. But there is no translation layer. Yeah, because it has its own processing engine. Yeah, it won't translate. You get the output, but there is no intermediate conversion in between. So there is no overhead in terms of translation. Yeah.
Babelfish produces the execution plan right from Postgres engine.
Yes. Yeah. Yeah.
In regards to migration, is part of the migration tool, so is it, you said it analyzes the schema, is it like a query analyzer too, where you can put multiple queries and get an idea?
Yeah. But, I mean, yeah, query, in SQL Server, we have query analyzer, right? Is SQL Server Management Studio. You're talking about query to write the queries or to analyze queries?
I'm talking about analyzing queries, so if you were to migrate, say, Oracle to Postgres, there's some sort of a tool where you can capture the queries that were run on top of Oracle, and then know how they might, have some idea how they might run in Postgres.
Yeah, you can use an explain command. There is a command called explain. And yeah. Yeah. Yeah, explain is. You can use explain command, or there are some views, statistics that gathers the statistics of your queries. And you can also use an open source tool called PG Badger if you're using an open source Postgres. Then you can get a snapshot view of the performance of your database, just in case if you want to compare side by side. Yeah. All right. If you still have any questions, then please reach out to us.
Yeah.
Those are our email addresses. Especially if you are planning to migrate from either from Oracle or SQL Server, or no matter whatever the database it is, to Postgres, then let us know.
Yeah. Thank you, everyone.
Thanks, everyone.